The next question is related to the turning effect, moment, and equilibrium topic. The diagram shows a drawbridge that is attached to a wall by a hinge at one of the end and the cable is at the other end. The weight of the drawbridge and the tension in the cable are represented by labels arrows in the diagram. And there's a third force at the hinge which is not shown. The drawbridge is in equilibrium. When object is in equilibrium, there is no resultant force. In a vector diagram, how we know that there is no resultant force? So when we add up those vectors, when we add up the vector, the starting point and the final point should be same. Like where we start the vector diagram, we'll also end at the same position. It shows that the object is in equilibrium or balance. So if we draw this, like this is representing the tension, then we have a weight. So this is representing the tension and this is representing the weight. So what should be the force, the third force at the hinge? So because we don't want the resultant to, there is no resultant, so the starting and the final point should be same. So this will be the force from the hinge. So it matches with option D because D is directed in the same way as the force it should be. Because so the simple concept, whenever object is in equilibrium, the resultant force is zero. To have a resultant force zero, there's no resultant force, no resulting turning effect. To have the resultant force zero, it means that the starting point and the final point of the vector diagram should be same. That's how we locate the position of the force or the direction of the force on the hinge.